ನಮಸ್ಕಾರ ವಿದ್ಯಾರ್ಥಿಗಳೇ. ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಆಗಿರುವ ಡಿಫರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ಸೀರೀಸ್ ಆ್ಯಂಡ್ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇದರ ಬಗ್ಗೆ ನಾವು ನೋಡೋಣ. ನಾವು ಲೆಟ್ ಅಸ್ ಬಿಗಿನ್ ದ ವಿಡಿಯೋ. ಮೊಟ್ಟ ಮೊದಲಿಗೆ ನಾವು ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ ಎರಡು ಕಾಲಮನ್ನು ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ ಆ್ಯಂಡ್ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಕೆಪಾಸಿಟರ್. ಸೊ ಇದರಲ್ಲಿ ನಾವು ಮೊದಲಿಗೆ ಡಯಾಗ್ರಾಮನ್ನು ಡ್ರಾ ಮಾಡೋಣ. ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಆ್ಯಂಡ್ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ capacitors like this. So now look at the diagram. Series combination. Here we have connected two capacitors in series and to a battery here, and two capacitors parallel here and connected to a battery. Charge on the capacitor here is same, okay, and potential difference across the combination divides. Here potential difference remains same, charge divides. These points we will continue now, okay. So the second difference we will note down. In series combination, of capacitors, how the capacitors are connected here. Capacitors are connected end to end, okay. The capacitors are connected end to end connection of capacitors it is, okay. And the next, coming to the parallel combination, how the capacitors are connected here. Capacitors are connected between two common points here. Let us say these are the 2 points here. So between 2 common points they are connected. Let us say here I will take A and B. Here also you can take, okay. So here these two are always connected between 2 common points here. So therefore the capacitors are now said to be connected in parallel. In parallel combination of capacitors, the capacitors are connected. Capacitors are connected between 2 common points. So we'll move to the third difference now. In case of the capacitors in series, charge on each capacitor remains same here, okay. In series charge on each capacitor remains same, okay. So here in parallel what happens, which quantity remains same here? Potential difference across each capacitor remains same, okay. Coming to the next difference we have, so which quantity divides in series combination. We saw that charge on each capacitor remains the same here, and potential across the capacitors. We already saw that in the diagram. You can see from the diagram here the potential, total potential across the combination divides. Total is V ಇದೆ, ಅದು ಯಾವ ರೀತಿ ಡಿವೈಡ್ ಆಗಿರುತ್ತೆ ಅಂತಂದ್ರೆ ಇವಾಗ, so it is divided into two parts, that is V1 and V2. So how the potential divides here? Such that it divides such that V is equals to V1 plus V2. Similarly, in case of the parallel combination, which quantity divides here? The total charge on the combination divides. So such that Q is equals to Q1. Q1 means charge on the capacitor C1. Q2 is charge on the capacitor C2. It divides. Q is equals to Q1 plus Q2. In series, the total potential difference across the combination divides such that total potential difference divides such that V is equals to V1 plus V2. Okay, so here in case of the parallel combination, in parallel, the total charge divided ಆಗುತ್ತೆ, charge on the combination divides such that how it divides? Q is equals to Q1 plus Q2. That means total charge on the combination is equals to sum of charge on the capacitor C1 and charge on the capacitor C2. Okay, fifth one, we will see the difference now. So equivalent capacitance in series is given by we have the formula 1 by Cs is equals to 1 by C1 plus 1 by C2. This is the general formula for equivalent capacitance of two capacitors. Okay, so here in case of the parallel combination, what is the equivalent capacitance formula? Equivalent capacitance in parallel is given by the formula we have, Cp is equals to C1 plus C2. Okay, these are the main differences. There are few more differences, but these are the main and important differences between series and parallel combination of capacitors. Okay, so here we stop our discussion about the differences between series and parallel combination of capacitors. Thank you. Namaskara.